It starts with a flash, blinding, violent, and impossibly distant. Somewhere in the cosmos, a massive star reaches the end of its life, implodes, and then explodes in a spectacular event we call a supernova. For centuries, these celestial cataclysms were seen as beautiful but distant phenomena, but recent research has revealed something far more disturbing. These explosions may not just light up the night sky, they might also have wiped life off the face of Earth. For decades, scientists studied extinction events, massive die-offs in Earth's history, like the one that erased the dinosaurs or the mysterious Permian-Triassic extinction. Traditionally, these events were blamed on volcanic activity, asteroid impacts, or climate change. But now, thanks to surprising new evidence, researchers are re-examining the role of space itself, especially deadly supernova. One of the biggest revelations came when scientists began analyzing ancient isotopes embedded in ocean floor sediments and Antarctic ice cores. They weren't looking for signs of extraterrestrial death rays. They were analyzing iron, specifically iron-60, a radioactive isotope not naturally produced on Earth. Its only known source, supernova explosions. Iron-60 has a half-life of around 2.6 million years, which means if we find it on Earth, it must have arrived relatively recently, cosmically speaking, and we have. Samples taken from deep-sea crusts and ancient ocean sediments show peaks of iron-60 around 2.6 million years ago, and again at about 6.5 million years ago. These match suspiciously well with two significant biological shifts on Earth, one being the Pliocene extinction. That extinction, though smaller than the one that killed the dinosaurs, still saw a massive loss of marine megafauna. The question scientists began asking was, could a nearby supernova, exploding within a few hundred light years, have bathed Earth in cosmic radiation intense enough to trigger biological collapse? The answer, it seems, is yes. And the mechanism is as terrifying as it is fascinating. When a supernova erupts within 150 light years, it releases an ocean of high-energy cosmic rays that can reach Earth and interact with our atmosphere. These rays aren't just light. They are charged particles, mainly protons, that crash into the molecules of our upper atmosphere, triggering a cascade of secondary particles like muons and neutrons. Muons are particularly deadly. Unlike normal radiation, which gets absorbed by Earth's atmosphere or skin, muons penetrate deeply. During a supernova radiation event, muons could reach ground level and even the ocean depths, disrupting cellular biology and increasing mutation rates in animals and humans. Large animals, with longer lifespans and more complex systems, would be especially vulnerable. This could explain why extinction events often disproportionately affect megafauna. And while we're on the topic of gamma rays, there's an even more terrifying cousin to the regular supernova: the gamma ray burst. These ultra-rare, ultra-powerful explosions could theoretically sterilize an entire side of a planet if they struck head-on. Earth has never suffered one that we know of, but fossil evidence from the late Ordovician extinction does show signs consistent with such an event. If one occurred in our galactic neighborhood, we might not even see it coming. In the past, this kind of theory might have sounded like science fiction, but with data piling up from iron isotopes to extinction curves, more and more scientists are starting to take the idea seriously. Entire fields are now collaborating. Astronomers, biologists, geologists, and even climate scientists are connecting the dots between stars and species, and the implications aren't just historical, they're future-facing. Researchers now routinely monitor nearby stars to assess potential supernova risk. Betelgeuse, a red supergiant just 650 light-years away, has become a household name after scientists noticed it dimming, possibly a prelude to explosion. If Betelgeuse went supernova tomorrow, we'd be dazzled, but safe. It's too far to cause real harm. But others, like Pegasi, are binary systems with the potential to go off much closer to home. So how close is too close? Most researchers agree that anything within 25 light-years would be catastrophic. The damage would range from ozone depletion to widespread radiation, climate shifts, and biological collapse. Thankfully, no known stars capable of such a near-future detonation are currently that close, but cosmic time runs deep. Stars shift. Binary systems evolve. It's not a question of if but when. The more we understand about supernova, the clearer it becomes that they're not just pretty fireworks, they're agents of chaos and transformation. Without them, we wouldn't have the heavy elements like gold, iodine, and uranium that make life possible. But with them, we face periodic resets, cosmic culls, and evolutionary disruptions that have shaped the tree of life. There's even a philosophical layer to all this. We often think of extinction events as tragic or random, but what if they're written into the fabric of our galaxy? What if civilizations, ours or others, are periodically reset not by their own mistakes, but by the indifferent blast of a star hundreds of light years away? The new research into supernova and extinction is helping us confront these questions. It's reminding us that while life on Earth feels stable, it exists on the edge of a cosmic minefield. Supernova are not just distant explosions, they're historical markers, biological triggers, and perhaps even the architects of fate. Another disturbing effect is the depletion of ozone. Supernova radiation doesn't just end with deadly particles, it can also disrupt the ozone layer, allowing more harmful ultraviolet radiation from the sun to reach the surface. This would further stress ecosystems and damage DNA. Suddenly, a star exploding millions of years ago in a distant region of the galaxy doesn't feel so far away. It feels close, personal, and lethal. But what if it wasn't just one supernova? Some scientists now believe we've passed through a whole series of them. About 10 million years ago, our solar system entered a region of space known as the local bubble. This isn't just a cool name, it's an actual bubble of hot, sparse gas thought to be carved out by multiple nearby supernova over the past 10-20 million years. Essentially, we've been traveling through a graveyard of ancient stellar explosions, and the effects of that journey may still be unfolding today. The most recent data comes from a surprising collaboration between astrophysicists and paleobiologists. These scientists combined isotope records, extinction timelines, and computer models of cosmic ray exposure to reconstruct a chilling picture. Every time Earth entered a period of increased supernova activity, there was a corresponding drop in biodiversity. Coincidence? Maybe not. One particularly striking case is the possible link between a supernova and the transition from the Pliocene to the Pleistocene era roughly 2.6 million years ago. This was when global climates cooled dramatically, leading to the ice ages. Some researchers suggest that increased cloud formation, triggered by enhanced cosmic ray flux, could have led to long-term climate changes. In other words, the explosion of a star could have tipped Earth's climate into a frozen epoch. If that's true, then supernova don't just erase, they reshape. They may be hidden players in Earth's history, quietly rewriting evolutionary paths and shuffling the biological deck. And the most unsettling part, we've only just started noticing. Other extinction events are now being re-examined under this lens. Take the Devonian extinction, which wiped out about 75% of life, some 370 million years ago. Though often linked to ocean anoxia or volcanic eruptions, new hypotheses suggest that a supernova could have been a contributing factor, possibly through ozone depletion and sudden UV increases. Ancient plant spores from this era show signs of severe UV damage. That's hard to explain with volcanoes alone. But a wave of gamma and cosmic rays from a nearby dying star, that fits the evidence. At the same time, new technologies are giving us tools to look further, deeper, and more precisely. Satellite observatories are mapping gamma ray sources, while neutrino detectors are catching ghost particles from supernova we can't even see. On Earth, deep-time drilling projects are hunting for isotopic traces that match distant explosions. We're building a forensic record of cosmic death and life's response. And here's the strangest part. There may be benefits hidden in the chaos. Some evolutionary leaps, like the rise of mammals or even hominids, occurred in the aftermath of extinction events. It's possible that supernova-induced climate shifts or radiation spikes acted as selective pressures that pushed life to innovate, adapt, and evolve. In this way, supernova may not just destroy, they may create. Still, the balance is delicate. The wrong blast at the wrong time could have wiped us out before we began, and perhaps it has elsewhere. The Fermi paradox, the puzzle of why we haven't detected intelligent life, despite the vastness of the universe, may have an answer in supernova. Perhaps promising civilizations are regularly culled before they can spread. If that's true, then cosmic explosions are not just part of the story of life, they may be the gatekeepers of intelligent life itself. Ultimately, what we're learning is both humbling and awe-inspiring. We live in a galaxy filled with wonder and violence. Stars give us light, warmth, and chemistry, but they also hold the power to end entire eras. The more we study, the more we realize that Earth is not an island. It's part of a vast, dangerous sea tossed by currents of radiation, shaped by winds of energy, and shadowed by ancient explosions. And maybe, just maybe, understanding this celestial dance gives us a better chance of survival, not just through detection and preparation, but through awareness, through humility, through remembering that even the stars, those ancient burning giants of the sky, are not eternal. They live, they die, and in dying, they reshape everything, including us.